RCExplorer built at speed, exploring the RC world one cache at a time.
In this video, I'm going to show you how to build the Tricopter version 4 with an F3FC board and all carbon parts. We're also going to use the Tricopter version 4 power pack, which includes the servo with feedback wire, which greatly enhances flight performance. Alrighty, let's get started. The first thing we're going to do is build a camera tray. So grab that bag and pull out all the stuff. This is everything you're going to need for this part of the build. Grab the bottom wire holders. We're going to sand these using some 80 grit sandpaper. This is so the pieces are nice and flat and you get good surface contact to the camera plate. This also creates small grooves that the CA is going to wick into and create an even stronger bond. You know that you're done when the whole bottom of this piece looks sanded. To create even better surface contact for the glue, you can use a knife and scrape the bottom here as well. Use a clean rag or cloth to clean off the pieces and get rid of all the dust that's accumulated. Dip the rag in some clean alcohol if you have it. This way the surface is going to be as clean as possible and the glue will stick much better. Sand the part of the camera tray that's going to be covered by the bottom wire holders. No need to go crazy here, but you want to scuff the surface. You can use the scraping knife trick here as well to get an even stronger glue joint. Make sure that you wipe it down afterwards to remove all dust and debris, anything that's going to reduce the strength of the glue joint. Also make sure to wipe down the vibration dampening wire, as it might have some oil residue on it. The stronger we can make the glue joint between these pieces, the better. Now we're going to dry fit the vibration dampening wires. No! This is the wrong way around. You want them pointing upwards, not downwards. Otherwise your GoPro lens is not going to be in the center. The wires need to sit all the way down in these cutouts. Otherwise the bottom wire holders are not going to be able to sit flush against the camera plate, and the bond is going to be much weaker. Use a knife to scrape away material until it fits perfectly. Do this outside and wear breathing protection and stuff. Don't sniff it. Dry fit the bottom wire holder. If it sits nice and flush against the camera tray, you're good. Glue time! Use medium viscosity CA. Make sure that you get a healthy amount of glue in the cutouts. Don't go crazy with the glue, but don't use too little either, because we need the glue to fill the space between the wire dampeners and the cutouts. It's a really good idea to have something disposable underneath these pieces while you work at them. You can use one of the plastic bags that the kit come in, because the glue sticks really poorly on the surface. Put the vibration dampening wires in there and then shove the bottom wire holder on top of it. Make sure that everything sits nice and flush and there's no gap anywhere. You want to apply pressure on these pieces, so I use 2 clamps and just clamp it down hard and then let it sit and dry for at least 10 minutes. Again, make sure that there's no gap anywhere. Now let it dry. Looks like I got the perfect amount of glue in there. There was not too much spraying out when I clamped it, just a little bit, and the joints looks really good. In case there's too little glue, you can always use some thin CA and wick it in there to make it super strong. Now do the exact same thing on the front one. Don't use foam safe CA because that doesn't stick well to this at all. Also, it's a good idea to have a rag close by in case the glue goes squirting everywhere. Another good tip is to use clamps that have the silicone coating on top of it. This way the glue doesn't stick to them at all. Look at that fanciness. Mine's a little bit scratched up because I get the second sorting of stuff. But hey, still looks pretty good. Now we're gonna build the arms. The parts you need for this is motor mounts and some screws. There are 2 lengths of screws in this screw pack. You want to use the 18mm long screws, not the 20, the 18mm. Very important. Open the motor pack and take out the screw bag. There's 4 small countersunk screws that we don't need, just throw them away. All we need is these pieces. The prop adapter is mounted using these tiny little screws here. And whenever you screw anything metal into metal, always use blue Loctite. Anytime, everywhere, all the time. You don't need a crazy amount. All you have to do is get it in the threads. You can wipe off the excess. Screw in the screw, but don't tighten it all the way. We need to mount all the screws before doing that. Otherwise, stuff can get crooked and out of alignment and all that. So just do not tighten them all the way. When you get all the screws in there, then you can start tightening one at a time. And don't go crazy, just move around in a circular pattern until they're all tightened down. That way you know it's perfectly level and good. Now we're going to mount the motor mounts to the motor. Use the 18mm screws. I cannot stress this enough, otherwise you're going to destroy your motor. use the 18mm screws. Get some Loctite on all of the screws and then put those screws on the motor and tighten them just a couple of turns. If you tighten them too much, you're not going to be able to get the arm through. Then pull the two motor mounts apart. We're going to shove the arm through here. Make sure that you have the hole pointing upwards at the same direction that the motor is going to be. Otherwise things are going to end up awkward later in the build. Push the arm in until it's flush with the outside diameter of the motor mount. Again, check where the hole is compared to the motor. And also make sure that the wires point in towards the boom. Now we can start tightening the screws. Do not screw one all the way down. Go around and just tighten each screw just a little bit each turn until both motor mounts sit flush against the boom. But don't go Hulk on me and over tighten these too much. You're just going to ruin things. Make sure that the motor is pointing straight up and down compared to the boom. If it doesn't, you over tighten one side of the screws too much. Now we're going to solder up the speed controller. We need to solder on some longer wires in order to get it to reach to the power distribution and flight controller board. This wire is included in the Tricopter power pack. Pull off the heat shrink and start desoldering the wires. I recommend using 60/40 solder and a nice powerful soldering station. Set the temperature to 300 to 320 degrees Celsius. Always add your leaded solder to these pads. This is because the original solder is lead-free, which melts at a much higher temperature. Also, adding your own solder will give you more flux and a nicer solder joint. Always retin the wires because they're lead-free as well. Always add more solder. Reduce the temperature when soldering these signal wires. 280 degrees or 260 degrees is powerful enough. Solder joints always look horrendous when you mix the two different solders, so don't worry too much about it. It's a good idea to protect the wires where they're going to enter the boom later, so we're going to use a 6mm wire mesh. A piece that's 8 centimeters is pretty good. An easy way to get wires through wire mesh is just squeeze the front end, push the back end toward the front end, squeeze the back end, and release the front end. That way you can kind of walk it forward. Or if the friction is low, you can just push it forward. To prevent the ends of the wire mesh to fray, you can melt the edges. Use something hot, like a soldering iron you don't like. Now we're going to solder the motor to the speed controller. This is where the ESC is going to be located, and the power wire is going to go towards the end of the boom. You need to decide if this is going to be the left or right arm, because you want the speed controller on the side that's not facing forward. Place the motor wires against the ESC in a loose arc, then cut them. Then strip the wires. I usually do around 5mm. Then twist the ends, and then tin them. Again, 300 to 320 degrees Celsius is a pretty good temperature to solder these at. Slide over the heat shrink and then solder the wire one by one. If there's too little solder on there, just add a little bit. Make sure that the wires are all the way down against the board. You don't want them soldered on top like a blob. That's going to lead to all kinds of bad stuff, like exploding speed controllers and burned out motors. Slide the heat shrink back over the ESC, but don't shrink it yet. We want to test which way the motor spins before that. Don't ever let the speed controller touch carbon fiber while it's powered on. That's going to fry everything. So put the heat shrink back on. Now we're going to snake the wires through the boom. It's easier if you remove the servo connector. Then just shove the wires through. It's not harder than that. Make sure that the end of the wire mesh doesn't get caught on the lip of the carbon fiber tube and frays everywhere. This boom is now down for the moment, so put that aside and do the other one. But remember to put the ESC on the other side so you have both ESCs pointing backwards where they're more protected. Now we're going to do the back boom, and we're going to start with the tilt mechanism. The tolerances on these pieces are pretty tight. When assembled, these parts should move with very little friction. More often than not, you're going to need to sand these pieces. You want to remove enough material to where the friction is low, but you don't want to remove too much either, because then you can develop slop in the tail, and that's not good either. Do not sand the side where the servo is going to be pushed into, because that's not going to do anything. Sand the insides of the pieces. When you're done with the heavy grit, you can go to a finer grit and do the finishing pass. Test the pieces often and adjust from there. This tilt mechanism is made from fiberglass reinforced nylon, and it was forged in the fires of Mount Doom, so it's pretty durable. You want to test the tilt when the screw is mounted. To reduce friction a little bit, you can over tighten it. Just keep on going and keep on going. That way it's going to kind of sand itself down a little bit, because otherwise you can get friction from the screw itself. When you're happy with the lack of friction, you can mount the tilt mechanism to the boom using 2 zip ties. You want the knots to point in opposite directions so that the force from pulling them tight don't pull in the same direction. That's going to make stuff crooked and sloppy. Now the servo needs some loving. We're going to extend the wire on it. The electronics kit comes with a 4-leaded servo extension. And we're just going to extend the wire of this 4-leaded servo that has a feedback wire on it. Cut the wires and then peel them apart. Cut the wires to slightly different lengths. This is so we can stagger the solder joints and have more space in the arm. Do the exact same thing to the extension wire, but the shorter wire should now be the same color as the longest wire were on the servo. Otherwise things is not going to match up and that's not going to end up good. Strip the wire on both the extension lead and on the servo. You want to expose enough lead to be able to twist the wires together later. That looks pretty equal. Before you start twisting and soldering stuff together, put on heat shrink. If you forget, it's going to be really painful to take stuff apart again, so just always put it on before soldering. The easiest way to do this is just twisting the ends together and then soldering them one at a time. Then we're going to fold one wire over. It's not the cleanest, but it does do the job really well. Wow, I'm really taking my time doing this. Might as well tell a joke in the meantime. What do you call it when you're sick of being at an airport? Terminal illness? Sorry about that. Fold the wire over and then slide the heat shrink over. Then just shrink the heat shrink. I like bundling up my wires before the heat shrink cools off. This way they stick together really well. Now add another layer of heat shrink, a big one. This is going to help reduce stress on the solder joints. Ooh, look at that. Now we can mount the servo on the tilt mechanism. Just put the little spacer on there and then shove on the servo for now. You don't need to put any zip ties on the servo yet because we haven't found out where the center is. We're going to test that when we have all the electronics put together. But now we're going to mount the back motor. Use the two 6mm long screws that are included in the tilt package. Mount the motor so that the motor wires point backwards, because this way you're going to get the least amount of interference from the wires when the tilt is moving. Don't forget the blue Loctite when screwing these things down. Please don't use the included countersunk screws in the motor package. Use the 6mm that are in the tilt mechanism. Cut the motor leads just behind the bullet connectors. Whip out an ESC and replace all the wires as you did with the two front arms. So I'm just going to fast forward through this. You don't need to get a super expensive soldering station. This one I use is 25 euros old. It's from Weller. You can buy it on eBay. Search the internet and check out what other people think is good and just buy a used one of those. Just don't buy a really cheap one from like Radio Shack. I recommend putting wire mesh on these cables as well because it's just extra protection. It's always good. In case you crash or something, it's not going to cut the wires. Okay, this is the way I recommend mounting the ESC. This way there's plenty of room for the motor wires to move around while the tilt is moving. I'm just going to temporarily strap this ESC in there. It's just going to make life a little bit easier during the build. Now feed the wires through the boom. Be careful so you don't fray the edges of the wire mesh. That turned out pretty good. Everything moves as it should. Wires look good. Everything is out. Nothing stuck in the boom. That means that all the arms are done for now, which is awesome because now we can start on the F3FC board. Flip the board over so you have the component side down. Plop the pin header in like this. It should be almost impossible to solder this on the wrong side because there's two less pins on one side. Flip the board over again and start soldering the pads. Sorry for blocking the light in this shot, but you'll get the point. Use a high wattage soldering station. Set the temperature at 280 to 300 degrees Celsius and use 60-40 solder. That should give you a result close to this. Next we're going to solder this little 3-pin guy. Pay attention now. This is going to go on the component side, like this, not on the other side. It's there to prevent the boom from sliding forward into your pins and shorting stuff out. So it's very important that you do this right. This is how it's supposed to look when you're done. Next we're going to solder on this little 5-volt beeper. It's pretty straightforward. All you have to do is just plop it in there, make sure that the positive is against the positive, and then flip the board over and solder it. After you're done, if the buzzer beep all the time, that means that you have a short between the buzzer negative and the power pads negative. So just remove that little thing and you should be good. An alternative way to mount the beeper is to bend the pins and then shove it in there from the side. This way it doesn't take up any space on the top of the board. The built-in switching BEC has a selectable voltage output. And on this build, I'm going to use 6 volt because that gives me a little bit more torque and speed on the servo. The standard is 5 volt, but if you want a different voltage, all you have to do is bridge those pads. On this board, there's also 2 other selectors for voltage. This one sets the URT1 output voltage. You can select between 5 volt and 3.3 volt. If you're using a Spectrum satellite receiver, it's very important that you don't power it with 5 volts, but select 3.3 volt. This little selector here is for the rest of the URTs and the 2 PWM channels. If you selected 8 volt output from the built-in BEC, this selector will let you use this little 5 volt regulator. This is so you can power very voltage sensitive URT devices while still using a high voltage servo. Do not draw too much current through this one though. It does not deliver more than like 200 milliamps, so no powering LEDs or anything then. Alright, let's plug in the receiver. We'll start with the PPM. It's very easy, you just plug it into PWM channel 6 here. The signal pin is located closest to the board, so mount it with the ground up and the signal down. That was pretty easy. Let's plug in a serial RX receiver. Here on the back you can see the URT pin out, so minus, plus, RX and TX, and the one we're interested in is plus, minus and RX. The URT1 pins are located closest to the board, and that's where we're going to plug the receiver into. The negative lead should point towards the I2C connectors and the signal towards the other end. Just plug it in and you're done. While we're at it, we can plug in the SmartPort telemetry wire. Just connect it to the TX pin on URT2 and you're done. That's it for the receivers. I thought I would show you some other ports while I'm at it. This is the I2C connections where you can plug in stuff like a magnetometer and stuff. All the way on the other side is the CAN bus. It's marked with an H and an L. And just behind there, there's a pin called LED. This is where you plug in those RGB programmable LEDs that are so awesome. Next to that you have PWM6. This is where you plug in the PPM receiver, and then next to that you have PWM5. If you go to the F3FC product page, there's some pictures showing all of this layout as well. And very last, on the front of the board there's a pad called raw. This will give you access to the raw battery voltage for powering stuff like an FPV transmitter or something. Lastly, this is how you plug in all the power wires. Your battery input power is soldered on here, plus and minus. That goes through the current sensor and then is connected to all positive and all negatives on the board. This is where the back ESC power wires are connected, plus and minus. The right and left power ESC wires come out of the boom and then connect to plus on one side and negative on the other side. Then the boxes that have the signal pads is where you should solder in the signals to those ESCs. Same with the servo wire and the servo feedback wire. I highly recommend plugging in the board to the computer at this point, just to make sure everything works before you start putting stuff together. In case the board doesn't connect, you might need to install some drivers. Take a look at the TriFlight setup video for more information. Now let's start soldering the board. Grab an arm and an 18mm long screw, and shove that through the frame and then mount the arm. If there's wire stuck in between the screw and the hole, just use a zip tie to poke them to the side and then shove the screw through. Make sure that you mount the right arm on the right side here, because you don't want the ESCs pointing forward. Loosely put in a nut so the screw doesn't fall out. It's a really good idea to add some kind of protection where the wires exit the boom. I'm just going to use some heat shrink. Make a piece that's long enough to rest against the screw and stick out a little bit. This way all the wire is going to be on the heat shrink, but you still have enough movement for easily unfolding and folding the tricopter. Be careful when you swing the arm over the board. You don't want to hit any of the components. I'm going to put in the stopper screw here in the front just to make sure that I have enough throw later. Strip and pre-tin the wires and the pads, and then just solder in the signal wire to the signal pad. Take care so it's the right one. You don't want it on the ground. Then just solder in the power wires. Note that both positive pads are on one side and both negatives on the other side. After you're done, test the whole throw of the movement. If your wires are too short, that means that the ESCs are mounted too far in on the arms. So adjust that and try again. Do the exact same thing on the other arm. This is going to take a minute, so I might as well tell another joke. At JFK Airport, a man was arrested trying to board a flight while in possession of a compass, a protractor, and a graphical calculator. According to law enforcement officials, he was believed to have ties to the Al-Ghibra network, and he was charged with carrying weapons of math instruction. Wow, this build is really flying by. Now it's time to do the back boom. Cut the wires to length, but make sure that you don't cut them too short. Since this arm won't be moving, there's no need to add the heat shrink for protection where the wires come out. Now strip the wires and separate the leads that go to the servo and the ESC. Twist the ends and then tin the wires. This greatly reduces the risk of a single strand poking out and shorting something out. If you're wondering about the wire stripper I use, it's called Weidmuller Strip Axe. I found this one in the trash can at my old electronics workplace. It's a little bit beaten up and it's missing some pieces, but I could bring it back to life. And now it's one of my favorite tools. Pre-tin all the pads. If you want something to hold the boom in place while you work at it, I found that the front spacer actually holds it down really well. Solder the wires to the board. Start with the difficult ones. I used a pair of tweezers here to hold the stuff down, but if I had been a clever man, I would have started with the back boom because then I would have had all kinds of room to solder this. So learn from my mistake. Set your solder station to 280 degrees Celsius when soldering the small wires. It's very easy to damage the insulation otherwise. Solder on the battery connector of your choice. I use a pigtail which has 5 cm long leads. I found this to be a really good length for the tricopter. Don't forget to re-tin the wires, otherwise you might end up with a cold solder joint. That's it for soldering the wires. Now take a good look at your awesome job. That was the hardest part of the build. From now on it should be smooth sailing. I'm going to use the super fancy carbon fiber bottom plate. However, the edges are rather sharp, so I use a really fine grit and just sand the edges really lightly. Do this outside and don't snort the dust. Wipe it down with a rag when you're done. You do not want any carbon fiber dust getting in the electronics. Now we're going to screw the frame together. You want to use the 20mm screws for this, not the 18. To get even better performance out of the barometer, you can take a piece of foam and stuff into the front spacer. This will remove the last of the airflow over the sensor and give you much more accurate results. Now we can put the nuts on the frame and start bolting it together a little bit. The screws that hold down the front and back wire holders do not need to be tightened down now because we're going to unscrew them a little bit later and shove in the wires from the camera plate. Again, the screws that hold the front and back wire holders should be 20mm long, otherwise they won't reach through the lock nuts. You can tighten down the screws that hold the arm pretty tightly now, and also the front stopper screws as well. Here comes the camera plate. Untighten the nuts on the back wire holders. Lift it up and slide in the back wires, and then put the screws and nut back. Do the same at the front end. I think I have time for another joke here. A Boeing 747 was taxiing down the tarmac. It abruptly stopped, turned around and returned to the gate. After 2 hours delay, it finally took off. A worried passenger asked the steward, "What was the problem?" The steward answered, "The pilot was bothered by a noise he heard from the engine. It took us quite a while, but we did manage to find a replacement pilot." You can now tighten down all the screws. Do not over tighten them though. You want the screws sticking up just a tiny bit through the lock nut. You can pretty easily over tighten these and bend stuff and break stuff, so be careful. Time to mount the landing gears using zip ties. Be sure to put the knots in alternating directions. This way you get equal pressures on both sides. Mount all 3 landing gears the same way. Now we're going to tune the boom resistance. You want the arm to be able to touch the screw but just barely. You want a good amount of friction there. Adjust this by tightening or loosening the front stopper screw. This is how mine looked when I was done. Notice that it just bows a little bit, not too much. Like, this is not how you want it to look. Notice how bowed that is, and you can't even get the arm touching the screw. You can also increase the overall friction of the whole arm swing by tightening down the screw that's holding the arm. The friction from those two things combined is plenty strong to hold during flight, and it will also absorb a lot of energy during a crash. If this is set up properly, it actually takes quite a lot of power to move it back. This is how the wiring looks when you fold the arm back. Pretty clean! Now I'm going to mount the receiver. I'm going to use an X4R receiver from FR Sky, which uses S-Bus and SmartPort telemetry. Plug it in the way I showed you earlier in the video, and then just strap it down using some double-sided sticky tape. To mount the antennas, we're going to do a pretty cool trick with just zip ties and some heat shrink. Put a zip tie around the front dampening wire and tighten it properly. Do the same on the other wire. Make sure that you get it nice and snug. Just one zip tie is not going to be tall enough though, so grab a messed up zip tie that you have laying around that you cut from something else and then cut that to a good length. Cut a piece of small heat shrink and put that over the zip tie. Then mount both of them on top of the other zip tie and then heat shrink that. Then cut a larger diameter heat shrink piece that's as long as the whole thing. Then slide that heat shrink over the antenna and the zip tie and then hit it with the heat gun. This is going to let your antennas stand nice and tall, get good reception, but still be very, very durable, because this can take a crazy amount of energy without snapping. They just bend backwards. And the zip ties being attached to the wire holder is going to make sure that there's no strain on the antenna at any time. Also, this lets you shove down the tricopter in a bag without worrying about the antennas. After you shrink the heat shrink, go over it with your fingers and kind of squish it. That way it sticks better to both the antenna and the zip tie. Look at that, that's a pretty clean setup. Almost no wires in sight. This is how easy you can bend the antennas back. Next we're going to set up the midpoint for the servo, but before you do that you really need to go and watch the TriFlight setup video. Okay, good, so you're back. Let's set up the midpoint then. As soon as you power on the copter, the servo will go to 1500 microseconds. You want the tail to stand as straight up at this point as possible. If needed, unscrew the screw and slide the servo out, and then move the tilt on the spline until it's as straight up as you can get it. Don't worry if it's not perfect, it's going to sort itself out during the unarmed tail tune setup. Over tighten this screw a little bit so the splines and the servo slide all the way into the tilt mechanism. Then screw it back out a couple of turns. Now we can fasten the servo using zip ties. Take 2 zip ties and tie them together. You always want the knot to rest at the corner of something, so place one on the corner of the servo and one on the corner of the boom. Mount the other zip tie pair in the opposite direction, so you have the knots pointing in the opposite way, like this. Get those zip ties nice and tight. This is how it's supposed to look on the bottom. And on the top. You can now go to Crazy Town and tighten down all the zip ties except the one that's loosely holding on the ESC. Then trim the zip ties. Now we're going to check if the motors spin in the correct direction. I do not recommend using the method I'm doing. Just use some piece of tape or something. This is highly inappropriate. This is the absolute best way to mount your props. Don't care about any other diagram or anything, this is the best. You can let the front motor spin in a different direction, but the tail motor has to spin this direction. Otherwise the stuff that's been done in TriFlight is not going to work. Your copter's going to crash and it's going to hurt when you pee. So heed my warning, mount the props this way. If your motor spins in the wrong direction, there's a pretty easy way to fix this. You can just desolder 2 of the motor leads and swap them around. Any 2 will work, it doesn't matter. This is why we left the heat shrink unshrunken before. But now if the motor spins in the right direction, you can shrink it. Use a lower temperature on a heat gun, otherwise the wire mesh might melt. Now you can zip tie the ESC in place. A single one is enough. Then you can tighten all the zip ties, even that on the landing gear, and then clip all of them. Now I'm going to remove the zip tie I used to hold the ESC in the back temporarily. This is so I can do the tail tune using the H that is included in the tilt mechanism. How you do this setup is described in the TriFlight setup video. You should have already watched that though. If you haven't, then shame on you. Shame. Okay, we're really close to the finish line now. Just put on a zip tie and cut that. The last thing we're going to do before we go out and fly is to balance the props. This is super important, otherwise the copter is not going to fly well at all. Start by mounting the 5mm inserts into the prop. If you don't mount these inserts, there's no point in balancing the props because it's going to be off later anyway. Get one of these high quality balancers, they're totally worth it. So this is the correct way you mount the prop on the prop balancer itself. Mount the side of the prop that has the insert against the cone-shaped piece. Then slide on the other cone-shaped piece, but use the flat end against the propeller. Then the spring and then the locking tube. This way the prop centers against the part that's actually going to center it on the motor later. As you can see on this prop, one side is clearly heavier than the other. We're going to fix that by adding some tape to the lighter side. Put it as far out as possible. Keep adding tape until the prop hangs horizontally. However, this is not the whole balancing process, because this propeller is horrendously out of balance in the hub. You're supposed to be able to put the prop at any angle and it's supposed to stay there. This one clearly does not do that. So we're going to fix that by adding some hot glue. Add glue to the lighter side, the one that's currently pointing upwards. Let that dry for a while and then test it again. This one is pretty good, not perfect, so you can either add more or remove some by pushing the nozzle against the glue that you already have and scrape some off. It's now time to mount your freshly balanced props on the copter, then take a step back and look at this beauty that you just built. Now it's time to go out and fly, finally! Good job on making it so far, and I hope you really enjoy your first flight. Don't forget to do the tail tune on the first flight. This is vastly going to improve the flight characteristics and your experience of this craft. So just do it. I really want to see pictures from your build. Go to rcexplorer.se/forums and post a picture of your craft. It would be awesome to see how you solve things. Also, write what you thought about the build video and the build process in general. I always love feedback. Thank you so much for watching, and thank you for buying stuff from my store. You're awesome.